Here's AJ's Gibson GA-15RVT. He got it at a pawn shop here locally. It's in beautiful condition. This is was manufactured in 1965 by Gibson Corporation in Kalamazoo, Michigan. This thing is in beautiful shape. But it has some problems. So I got it over here on the bench. AJ says the reverb and the tremolo don't work. The rest of it works fine. So I'm going to take it apart, see what's going on. So I have the amplifier on my bench here, and I've noticed a couple things already. First thing, it has a power polarity switch up here, which does the line and neutral switch. But this amplifier has been reworked at some point, and it has a 3-prong AC cord on it. So I got to check out to make sure that this was done correctly when I take it apart. Like I previously discussed, the tremolo is not going to work unless you have a Footswitch installed. So I don't expect this to do anything. And the reverb, we'll check that out as well. But I did notice a few things before I even got started. If I take my guitar cord, I have my guitar here. If I take my guitar cord and I just touch the tip to the ground leads on the surrounds here on the ground to the plug-in, it's kind of noisy. You can hear it popping. That's not good. The other thing I noticed was when I started hitting it, it also makes a lot of noise. So there might be a bad tube in there as well. When you do plug it in, it has it's got some kind of odd thing going on. First thing is, it's got a little bit of a hum, so I'll have to check out the capacitors, the filter capacitors on the power supply. And then when you plug it in, it does work. But you can hear it kind of crackling. It kind of comes and goes, so it's got this fluctuating volume problem. And it's kind of uncharacteristically distorted at this volume level. So I've got a little bit of work to do. I'll dig into this and we'll check things out. So I have the back door pulled off here, this thing here. And I pulled out the reverb unit. This is a spring unit that was in the bottom. It's in like a little leather pouch. I took that out as well. I have this thing tipped on the side, so I take the screws out, it doesn't fall in. I'm going to slide it out. Here's the inside of the Gibson, and this definitely is not factory. This pink zip tie here. It looks like they brought in the line. The ground is connected over here to the frame. That's good, and then it makes a connection over here. I'll check all this out. So here's the power transformer. I don't know which one this one is. That might be a filter choke. It does look like there's some old paper caps in here. I'll check those out, but someone did come through and actually measure the capacitance on these. I'll check the leakage on those as well. And then it looks like somebody might have come through here and put all these new caps in here. I'll check those. Other than that, it looks pretty clean, and I think that's going to be fairly easy to find the problems with this. Now we're looking at the underside of the amplifier. I got it tipped upside down. The power cord comes in. Here's that rework with the orange zip tie. This is the power transformer. It looks like it's got a little rust on it. Kind of unusual for our area because it's so dry here. So this amplifier probably existed where it's a little more humid. I'm gonna slide this thing over. These are the two output tubes. These are 6 BQ5s. They're equivalent to an EL84. This is the output transformer. This is the interstage transformer that drives these guys. It also does a phase inversion. This is the driver at the 12AX7 for this transformer here. These are the two preamp tubes. This guy is the transformer that drives the reverb tank. Here's the coax cable that goes to it. Here's the Footswitch goes, and this is the return from the reverb tank. I believe several different people over the history of this amplifier have worked on it, because written down here is 2 versions of the tubes, which means that a technician came in and hand scribbled on at some point what these tubes were, and then somebody else came in and they wrote the exact same thing again. So this thing has been through some rework at least twice, and so I'm the third. I'm at least the third. Here's a couple other observations. I think that these 2 wires here are the filament voltage coming over. They're not twisted together. In fact, there should be a pair going to each of these tubes that's twisted together. That cuts down on the hum. That wasn't done at all by the factory. And I want to mention over here, these are the rectifier diodes. These have been replaced at some point. I don't know if Sanyo was actually making diodes in 1965, but these 2 diodes are not of the same type. That shouldn't really make a difference in the performance, but I might consider switching those out for something that they're the same. And then whoever did the rework on this power cord, they did a crappy job. The reason being is this distance here between the stripped insulation and there's this giant glob of solder. They didn't bother cleaning off the solder off of the end of this fuse holder and actually making a mechanical connection here. So I'll redo that one. And this one is the worst one right here. This one's kind of indicative of what's going on. Let me see if I can zoom in on this guy. So instead of actually unsoldering all this, and this is the line connection coming in, instead of unsoldering all this and doing this right, they just cut this wire off and stripped it, and then they butt soldered these 2 pieces together. And when you spin this around, you can see that there's not even any solder on this side of the connection. This is really crappy work that's been done on there. I'll go ahead and fix this up as well. I need to check out these 2 capacitors. There's actually 4 in here. There's 2 on each. This one is 2 20 microfarads at 450 volts, and this one's 2 20 microfarads at 300 volts. These are the main filter capacitors for the power supply. These guys look pretty old. These ones might be the original ones because they're riveted into the enclosure here. I have 2 devices here to measure capacitance in my lab. One of them is a Syncor LC53. It's an impedance analyzer. It can measure capacitors and inductors. On the capacitor side, it can measure the value of the capacitor as well as the leakage current. Leakage current's actually done at the working voltage. So when I measured these guys here, they actually measured out about 20 microfarads, and the leakage current was within normal range. But that doesn't tell us the whole story. We need to know the equivalent series resistance, or ESR. So I have this other thing, and I don't have a piece of fancy equipment for this other measurement. I have this $20 LCR ESR bridge that I bought. Hook a 9-volt battery up to it, and you can put whatever you want in these probes here, and it'll measure things out. So it magically goes out and determines what you have connected. So you can see that I have a 19 microfarad capacitor, and its ESR is 76 ohms. This is excessive. That's this one over here. I measured the ESR on this one. This one's 1300 ohms. These capacitors definitely need to be replaced. We'll start here with the amplifier work, and we will continue on after I've replaced these. This is the reverb tank off of this GA-15. Let's take a look at what's inside of here. It's got a cardboard bottom. It's taped on here, and it's kind of come loose. I'll fix that before I put it in. I'm going to go ahead and show you what's in here in case you haven't seen this before. It's 2 springs. This is the input here, so a signal comes in from the amplifier, actually induces some vibration into these 2 springs. It looks like these springs have a different spring constant, which effectively is like a filter mechanism. So one of them is for a low frequency and one is for a little bit higher. These, when the electrical signal comes in, it's passed down this spring, but it's time delayed once it gets over on this side. This is a pickup that senses the vibration of these springs, and that's fed back into the amplifier, back into the main signal feed. And so a portion of the waveform that's coming out of the guitar is delayed through the spring action and fed back into the audio circuit. Let's check out what the ESR is for a brand new capacitor. I got this bag out of my high voltage capacitor location. These are 22 microfarads at 450 volts. These are electrolytics. I've got this one right here connected up to my meter. Let's measure it out at what was that, 21.33 microfarads at 7.8 ohms. That's significantly different than what's in the amplifier now. Also, this capacitor is significantly smaller physically. I do have larger capacitor values like 33 microfarads and 47. I'll determine which value I will actually want to put in the amplifier, but I'm definitely going to swap out those power supply capacitors in this GA-15. Earlier this week I sorted these capacitors from that estate sale in Los Alamos. I think I got all these capacitors for probably about $2. I sorted them by voltage, by working voltage, and some of these are fairly expensive. You know, these ones are all, these guys here are all Cornell Doublier. These ones over here, these are all Spragues. In fact, most of these are Spragues. And this is my bag of high voltage capacitors here. These ones are all like 250 or up to 450 volts, including some of these black ones down here. These look like original paper capacitors. I did test some of these for both ESR and leakage, and most of these are fairly new. Well, new. New as in 50 years old. I decided to go ahead and remove these old caps, and these guys were riveted in, so I drilled out the rivets and I got the rivets pulled out. And then based on a recommendation from Uncle Doug, when I mount my new caps, I'm not just going to dangle them in here or hot glue them in or some kind of crap like that. I'm going to go ahead and put this terminal strip in, so I have some holes drilled in here, and I'm going to mount this thing in with maybe some rivets and solder the new bypass caps right onto this terminal strip. There's a bunch of filings in here, so I'm going to go ahead and get a vacuum and suck those out. I've completed the work on replacing the main filter capacitors. These guys here, even though someone went through at some point and wrote on them, these are really bad. So we pulled those out. And I also found this guy here. This one is a 20 microfarad capacitor. This is on the cathode bias resistor for the push-pull output tubes. This one was bad as well. That's probably the reason why the gain was so crappy. So we're looking forward to doing that, to seeing how the effect of this one replaced is. Then if we come back down here, here are the main capacitors that I replaced. I put in two 22 microfarads at 450 volts, and then I put in two 33 microfarads at 450 volts. These ones are down on the preamp stage. And that other capacitor over here is from that bag of Sprague capacitors that I got. So this was, I did test these guys, all of them, and they all look great. So we'll plug this in and we'll see where we stand on the repair, and we will plot our course after we our findings from that. When I was replacing these filter capacitors, I had to drill out the rivet that was holding them down onto the board, onto the chassis. So in order to get access to drilling, I did pull out the output tubes, so the drill wouldn't hit it. And so now I'm in the middle of doing my mid repair test of the amplifier to see what's next to work on. And I noticed this little wire sticking out of this one of the tube sockets. I was like, I wonder where that came from. Well, it turns out it came from one of these tubes. Let me see which one it is. It is this one right here. These are the output tubes. These are the 6 BQ5s. This pin right here has come out of the tube. So we have a little problem. We're going to need to find another one of these. I think I have some of these. And plug it in and see what happens. Otherwise we may end up having to buy some more output tubes. Here's the transformer that drives the reverb tank. When I first picked this up, this cable here was just dangling off these terminals. There was no strain relief, so any kind of activity in the back of the case would actually pull on these transformer posts. And when I went to unsolder them, I don't know if it was because of the pulling in the past or me unsoldering them, but I got an open circuit on this side. That's a horrible news. I went and watched Uncle Doug solve this by cutting this out and resoldering these terminals on there, but I just got lucky and I heated these guys up again and pushed them back down in there and held them, and I was able to make the solder joint down underneath here. Then I added these strain reliefs. They're not pretty, but it's fine. You're not going to see them. And this is going to keep this cord from pulling on the solder joints. So here's a few things I noticed when I was working on this amp. I did mention that about 2 people worked on this before, and there was some pretty crappy workmanship. When I got down and I had to replace those capacitors, the way that those were stuck in the binding posts made it so I had to take all the wires out. And you could tell that when this was manufactured, it was done with a lot of quality, because everything was wrapped around and there was a mechanical connection before the solder was made. And that's what I learned in soldering school, is that you need to have a mechanical connection. Which made it a bitch to take apart, but I did get them all apart and I put those caps in. My little soldering station here for surface mount work is just barely usable for this type of work, just because of the gauge of the wires involved and how many wires were actually on these binding posts. I had to kick that tip up to 400 degrees to get it to work. Other things I had to get out were I haven't used this thing in years. This is a solder sucker. I couldn't find this. I found it much later, but when I was doing the work, I ended up using solder wick. So I must have there was so much solder in here. Whoever also did the work, their philosophy was more the better, and that's not really true with solder. So I had to go in and kind of clean up previous solder joints, and I must have used about 2 feet of this stuff. This thing of course I found this after I did all the work. The other thing is I had to get out my very large gauge solder. I rarely use gauge of this size. This is, what does this say? This is almost a millimeter in diameter. The gauge I use is almost like 30 gauge wire. It's very small. So on this thing here, let's give it a try before I put it back in the case. Where there's 2 bits of luck that we did have. That transformer wiring for the reverb tank, I was able to make that connection underneath the inside the transformer without having to take that apart. That was really lucky. The other thing that was lucky was, remember that 6 BQ5 pin that had pulled out? It just turns out that was pin number 8 on that tube, and it's an unused pin. So we got lucky twice today. We're able to get to the point we're going to do the final checkout right here. I did find, the last thing I did was, AJ doesn't have a Footswitch for this, and they're almost impossible to find. So the tremolo functionality, the Footswitch is not a disable functionality, it's an enable. So you need the Footswitch in place in order for the tremolo to work. The reverb itself is just the opposite. The Footswitch actually disables the reverb to work. So in order for this tremolo to work, what I ended up doing was I soldered in a wire inside the amplifier to mimic the Footswitch. If AJ ever gets one, we'll have to take this back apart again and unsolder that wire. But now I know the tremolo works and the reverb works. But let's do one final test here. So I got my guitar here, and it takes about 10 seconds to warm up. And you can't see it, but off camera I'm running that Polk audio speaker again on my test speaker. So this is our loudness of about 5, and I'm over here. I got both pickups over here on the middle is 5. So that sounds good. Here's the reverb. I'll turn the reverb up to about 6. So the reverb works. I'll turn that back off again. I turn up the tremolo itself. The frequency does work as well. And the depth. We are ready to put this back together in the case. I'll be back here in a few minutes, and we'll do the final checkout, and we'll turn this baby up and see how it works in the cabinet. I have the amp back in the cabinet. Let's turn it on, see how it works.